Okay, everybody, let's take a quick journey through kind of the next step of our process for writing your thesis or dissertation proposal. The idea here is simply to take time at all on wording or crafting beautiful flowing technical language prose or anything like that. Just getting things in a very basic general sense of order and logical structure. So first we, again, went through top level headings. Introduction typically comes before literature review, which typically comes before your method section, and that typically comes before anticipated results, which is then followed by work cited. At the very topmost level, not even worrying about any specifics. Again, these top level headings might be chapters in your eventual thesis or dissertation document, but for now, it's instructive and it's facile enough to get those first level headings in without, again, worrying about any wordsmithing, okay? We want to keep moving quickly at this stage because we are organizing things without bogging down at any of these steps. The next major accomplishment that we've tackled so far was to put in second level headings or subheadings underneath each one of those top level headings or eventual chapter titles. So second level headings inside of the introduction might be scope of the problem. It might be things like, what is the boundary around the time era of your phenomenon under research? It might be things like particular places where your topic under study is a relevant and pressing concern. Under the literature review section or the previous work section, it might be sections, subheadings, second level headings, like the name of your first major body of theory that your research was on. It might be a generate search or inquiry that might be research. Might be nitrogen cycling in the Midwestern United States following 1950 in agricultural field. So things that are a little bit more specific than those top level headings, but still not sentences, no citations with those headings. It's just, again, organizing things, but at a slightly more topical level. So having done those two initial steps, again, today we are going to start putting in bulleted key phrases, sort of quick notes to ourselves on key citations. This is generally where in my proposal I want this particular key previous study to go. It makes sense in this part of the narrative and so forth. So here at last, we're starting to actually put in content, but again, not worrying about sentences, no wordsmithing, just get it out of your head and onto the screen or onto the page if you're handwriting this. Okay, so today I'll take you through a bit of an example with that, and we'll start from scratch and just kind of see how that goes. I'll post this document as kind of another example of how your dissertation or thesis proposal outline should look at this step on our course website. So keep an eye out for that link in the announcement for today's session. Okay, I'm going to screen share just a blank Microsoft Word document, and I will briefly rough in the sections that we've previously talked about and go from there. All right, so let's get the zoom level about right there. Here we go. So my front matter, or you can just skip right into things like introduction. The actual first underneath that will be things like preface, foreword, which is not the same thing as a preface, your table of contents, your list of figures, list of tables, list of maps, list of, list of diagrams, illustration. So for those of you not sure if you're going to use things like list of diagrams, our sense here is that generally speaking, list of figures is going to cover everything that is any kind of a picture or diagram or map or what have you. But in some cases, your advisor or your committee might have somebody who's a bit more of a traditionalist and they want these lists separate out. You're manning the printed out, the dead tree version of your thesis or proposal. Okay, so when in doubt, stick with a list of figures. And later this semester, I'll teach you how to have Microsoft Word automatically generate and repaginate, that is, all of going to go. In addition, other kinds of front matter sections might be acknowledgements. And I'll help you decide what's appropriate to put in one or two paragraph acknowledgements section. Typically, it's people that will actually see this document and so forth. Okay, so sometimes you get sort of the Oscars or Golden Globes awards ceremony, just laundry list of people and family members and pets and deities and so forth in acknowledgements. Other times it's much more tightly constrained to the list of people that actually helped you physically with your project or intellectually. Okay, cool. So along with that, you can have things like a page which, even if it's not in this document, still applies legally here in the United States. That is a copyright. Anything that you create is automatic under your accepted parts of it that are, but international copyright law automatically and instantly applies the moment something is created, and you don't necessarily have to acknowledge that. But it's the people that are making this stuff up. Let's get on to the top level headings across the actual content of your document. Again, this will be things like introduction, your literature review, then typically methods. There is a difference between methods and methodology. We'll have a chance to get into what that is later on, but usually for a thesis proposal, especially, we're talking about methods, not so much methodology. Maybe for a dissertation, you might be talking methodology too, but another conversation for another day. After methods, sort of the recipe or laundry list of things we're going to do to actually accomplish your project over time. We, in a proposal, can't talk about any results or discussion or management implications or recommendations for future research. We don't know what those are going to be yet, but we can have a short section either inside of methods or typically right after for anticipated results. So I'm going to put that as a top level heading, but more commonly it's actually a subheading under methods. Following anticipated results, we've kind of got nothing else left to say in a proposal. We're just sort of describing work we are thinking about doing, sort of an informal contract between us and our advisors, our graduate research committees, and so forth. So from there, it's pretty much into just the bookkeeping stuff like works cited or a bibliography. And a works cited and bibliography are different terms, again, just like methods versus methodology. We'll talk about that difference another day. In a proposal, it's unlikely you're going to have any appendices or appendixes. These days, you can use either word. But we'll throw it in there just for reference, just in case you know where that would generally go. All right. Next, let's go back up to the introduction top level heading, and I'll zoom in here a little bit more so we can hopefully see that a little bit better with this kind of streamed resolution video. Underneath the introduction, we can have things like a problem statement. And that's identifying to the reader that this is not a pure science, which is a search is completely undertaken just to generate new knowledge, not necessarily to apply knowledge to a pressing problem in the world through technology based on science and so forth. Okay, so a problem statement, you could have a historic context section, or maybe a spatial context section. Again, these are pretty general subheading topics. For your project, the spatial context might be subtitled something like, agricultural drainage effects, tile drainage effects in the Midwestern United States on water quality in fluvial channel systems. So when we spray a bunch of pesticides or nitrogen-based synthetic fertilizers built out of fossil fuels, what happens when some of that washes off into the tile drain and then off into the Mississippi River, and then all of a sudden down in the Gulf of Mexico, we've got the Mississippi hypoxic and tens of thousands of square miles of dead fish. Okay, so that would be a spatial context, but a more specific spatial context subtitle for that particular research project. Okay, so think what might be a good spatial context subtitle for your project, or its historic context if it's more of an issue in that sense. For human-focused projects, of course, it makes sense to have a social context section. And kind of imaginarily, it's probably not useful to create these as subheadings. Underneath your secondary level headings that we're working on here. But within the problem statement and within each of the rest of these context sections, you might think about something along the lines of, what's the most sort of general introduction statement that we can do? So work general to specific. What's the general problem? And then following that sentence or paragraph, depending on how long your thesis or dissertation proposal will be, what's a more meso or middle scale clarification of the problem? So mesoscale problem. And then what is the specific problem now that you've narrowed down the intellectual landscape, so to speak, and brought down our radius of focus down onto a specific problem in a specific place, specific social context, etc. Okay. Now, for some theses and dissertation proposals, it makes sense to have the problem statement at the end of the introduction. So because we're doing this as an outline instead of lots and lots of paragraphs or sort of disorganized text so far, it's very easy for us to cut and paste or highlight and drag the different parts of this outline into a more effective order. So now we've got historic, spatial, and social context before the problem statement. So think for yourself, what makes the most sense? Do I lead off with a problem? Do I lead off with the context around the problem and then kind of zero in on the problem as I go? All right, so our last two steps were to, again, get through these top level headings like introduction, and then our second level headings, just short, general to maybe more specific phrases as second level or subheadings in a very basic order. Again, we can move these around at this stage without any real penalty, but we're not really in a restructuring or editing mindset or mode at this stage. Again, today's goal or approach is to tackle the next tiny little chunk. And this one is a chunk that we're going to iterate on. So we're going to repeat this step over and over and over, kind of until it's done. So underneath historic context or spatial context, let's do that one. Let's start putting in just phrases. Don't worry about wearing yourself out, crafting a bunch of sentences and citing things fully and clearly and so forth. This is totally just a living, working, early draft. We don't have any facts in this outline yet at all. We're going to start putting those facts in today, but without any wordsmithing. So underneath spatial context, maybe for our um, so a beef bovine genetics improvement, an animal science or veterinary research thesis or dissertation proposal. Maybe the spatial context here is, we're talking about the North American, specifically United States cattle industry. Okay, now this factoid is obvious to you as the researcher if this is your project. You've been talking with your advisor for maybe months, maybe more than a year at this point, about what your project is going to be, what the scope is and the scale. We're not talking about the beef industry that is opening up in sort of the southern Siberian range as the tundra permafrost opens up across sort of middle northern Russia. We're not talking about the Brazilian beef industry based on Amazon deforestation down in the southern hemisphere. We're talking about the United States beef industry. And again, you know that this is obvious to you, but your readers have zero context when you say uh, improving beef genetics. It could be anywhere. It could be any when as well. It could be under any um, political or kind of scientific or other ways of knowing regimes. So we want to make explicit your implicit understanding of what's going on. So again, very general initial spatial context clarification, your first bullet point factoid, providing any content. And there's no citation for this because you're just talking about the United States beef industry. So just right on to the next bullet point. So I'm talking us through this and it's a pretty slow process, but as you are kind of throwing ideas onto the page, I hope that you find this part is actually kind of fast. And hopefully it feels pretty satisfying to see this document uh, expand rapidly at this step. Again, before we go any further, remember, this is an iterative process. So this is the kind of thing where you want to work on this for an hour, stretch, get some water, do something else, feed your brain, which is using about 1/3 of your blood sugar each day, with some healthy foods, and blow off steam, getting some good exercise and so forth, and then come back to this with fresh eyes, renewed energy, and giving yourself time to sleep on whatever parts you get stuck on so that your subconscious can kind of chew on those overnight and then come back to it ready to go the next day. All right, cool. So back into spatial context. Let's say we've gotten a couple of bullet points in terms of actual content underneath this particular second level or subheading. And we're now ready to go beyond the most general. So we want to maybe define a term early on. So talking about this is industrial modern Western agriculture in terms of CAFO style operations, captive animal feeding lots. So that's what a I just want CAFO definition, then about antibiotic if this is your project. You are aware that antibiotics are you both keep these sort of high density animal feeding operations from having things like swine flu roll through and have to slaughter the entire population. And a very nice side effect, and sometimes the main goal for antibiotics administration across industrial beef farming, is to increase the size of the animal more rapidly. Antibiotics have this bizarre side effect in that regard. So antibiotics used to increase marketable biomass. And once we get past this stage of just doing these super brief, still actually pretty general bullet points, again, with relatively few citations. If this is your research area, you understand that there are hundreds of citations just applying to this bullet point, but we're not gonna bog down too much. We wanna kind of map out where we're going generally. And so maybe at this point, it's appropriate to keep ourselves from bogging down on wanting to throw in a bunch of citations with antibiotics use. We're still laying out the general landscape to get from the start to the finish of your proposal. So let's skip over to methods intentionally, if this is a useful workflow approach for you, so that you don't fall into the temptation to sort of grind to a halt looking for a bunch of citations on the antibiotics bullet point, the first content bullet point along that particular line of thought. So maybe your advisor has talked with you about different parts of your methods. So this will be things like the subheadings will be things like your sampling design, your data collection protocol is different than your sampling design or how you're going to make this data set statistically representative. Your quality control and error checking protocols. What statistical and non-statistical techniques are you going to use? Maybe that you've talked with your advisor or had a statistics lab on doing to find transposition errors where you meant to type 49, but you typed 94. There are statistical ways to find those. Outlier detection, for example, pattern recognition, signal analysis. There's lots of different ways to do it. So how are you going to do it? You want to maybe mention some of those. So sampling design, data collection, statistical analyses, and especially at the master's level, you really don't need to stress too much about the statistical analyses section here. For a lot of us, your master's studies time period of your life is your first real exposure to using statistical tools that have been developed and are now these days really pretty sophisticated and so forth. And you're not inventing anything here. As a master's student, we're mostly just using these tools that have been fine-tuned and honed and created for us, and in some cases with us, for our own ends. At the PhD level, you're a little bit more likely to be inventing a new statistical procedure to answer your specific, very, very, very laser-focused, pinpoint specific research questions. But again, at the master's level, not a huge concern for us. We're just going to be able to say we're going to use Tukey's post hoc analyses to find statistically grouped individuals within our sampled population. We're going to use k-means cluster analysis to try and define what some of those groups might be using a statistical justification. We're going to use structural equation modeling to define each step and relationship of the different nodes of this process that we have been talking about in our research group meetings and so forth, okay? But you don't have to invent any of those. At this point, again, we're just outlining, not even necessarily citing the creators or the polishers, the improvers, the harnessers of these statistical analytical techniques. We're just getting the word out on paper so we don't have to think about that. We can always circle back and put in more detail, okay? And I'll help you after this class session to know when enough is enough. Last class session, we talked about the idea of theoretical saturation, how to know when you've got enough literature sources for any particular part of your proposal or your eventual thesis or dissertation. When the next paper is not teaching you anything new about this particular area, And the next couple of papers after that are kind of the same. They're just other perspectives on the same thing that you already know. That's theoretical saturation. We have a similar kind of procedure for citing things like statistical analyses. Okay, so under statistical analyses, we might say univariate summary statistics. So that's things like, what's the average of this particular variable across all of the participants or organisms or analytical units in our study? Just what's the average biomass of each one of these beef cattle, sort of loaded, including food and water and so forth, versus the average dry mass of each one of them if you totally desiccated them after humanely sacrificing them in a drying oven, for example. So just a bunch of univariate summaries, mean, median, mode, range, standard deviation of each one of those variables. Each of those is a univariate or single variable summary statistic. Remember that a statistic is just a number that summarizes other numbers. So a summary statistic summarizes other statistics. Cool. Next, a very common sort of progression would be bivariate statistics, things like cross tabulation and correlations between individual pairs of variables is the how related to to the mass of the animal. Yeah, typically it is. Not always perfectly, but there's some kind of a general relationship there that's observable when you plot the information. So bivariate summary statistics would come next, and then usually these days, we're not generally able to kind of stop with bivariate stats. The problems that we're looking at these days are fairly complex and may involve anywhere from 3 to hundreds or thousands of input variables studies. So those are multivariate statistics. And then from there, you may or may not get into particular kinds of statistical models. All models are wrong. Some of those models are useful in that every model is just an approximation of reality and is not a perfect representation, but it is a human functional distillation of the important parts of reality. So it is wrong, but it might be useful. And so we have a lot of statistical modeling techniques that might be useful for you. I'll go ahead and put a couple of examples in here just to help remind you and connect your stats classes to how that set of techniques that you talk about in EdPsych 501 or biostatistics or what have you, how those actually map into things you're gonna do day to day in your analysis phase. All right, so univariate summary statistics, mean, median, mode. So these are all so-called central tendency. What's the center of mass of the values across the range of all values in that particular variable? What's the range itself? Max minus the min. What's the standard deviation? How tightly clustered around that central tendency value is your data set for each individual thing? Are they all very, very close to the mean, like within your precision, that is your last decimal point for that value? Are they all over the place and there's no real central tendency when you plot those values visibly? They're not clustered together on the graph space for that, or the pictorial space, so to speak, for that particular variable. Okay, so mean, median, mode, range, etc. There are a bunch of those. Bivariate stats will be cross tabulation. What's the count of every combination of variable A's values and variable B's values? When you arrange those as rows and columns in a table, how many individuals in your study population are in each of those cells? Okay, so this is a counting, this is a surface building. We're building a 3D surface as the values of the table for the X variable and the Y variable. Where do they combine? What's the height of each table cell if you're a visual and spatial thinker? Okay, so cross tabulation. With cross tabulation, we might see a chi-square type test to see if there is a statistical basis for saying, this is not a randomly evenly distributed table or surface of combinations of values in variable X and variable Y. There's something going on here. A chi-square helps you put statistical basis to that assertion, okay? Let's see, other bivariate stats would be things like basic correlation. When variable X goes up in value, do we see a corresponding or correlated increase in variable Y's value in that individual in your studied population? Or is there an inverse relationship where it goes the opposite direction? Okay, so that can be positive or negative, okay, based on the direction of that relationship. All right, other bivariate statistics that are very commonly across most kinds of theses and dissertations might be things like difference testing. So t-tests, for example. Okay. And for all of these general families of statistical techniques or tests, we're going to have parametric versions and non-parametric versions based on, is my sample population, are they generally normally or Gaussian distributed? If you haven't had a stats class yet, you're going to learn a lot about that. Or if it's not Gaussian normally distributed, is it gamma or Poisson distributed? Is it even or uniform distributed? Is it, there are tons of different statistical distributions. And the distribution helps you pick which flavor of the chi-square or which flavor of the various t-tests that are out there or difference tests that are out there. Okay, and those will be grouped into parametric. So typically Gaussian distributed in both variables versus non-parametric tests, which can handle smaller sample sizes, less regularly distributed. It might be multimodal. So values in that variable are clustered around 2 or more spots instead of sort of evenly grouped all together in a one big peak on the graph. Multivariate statistics are like, let's see, we can't forget ANOVA in bivariate stats. See ANOVA in bivariate stats, we also have, in addition to analysis of variance, ANOVA, we also have ANCOVA, which is analysis of covariance. Well, if we have multi-ANOVA, then we can have multi-ANCOVA or MANCOVA or MANOVA for the corresponding multivariate. Okay. And then moving down into statistical models, statistical models can be as small as bivariate. They can be as huge as thousands or hundreds of thousands of input variables. Organizations like Google, for example, track many thousands of things about searches, for example, and build emergent models out of that. So statistical models at a very basic or introductory level might be a linear model. Is there some kind of a linear line or straight line we can fit on a graph that generally describes the behavior of the individual data points on that graph? Do they sort of fall along that line fairly neatly? Do they fall along that line in sort of a cone shape or a spray? That's another sort of statistical deal that we can adjust for and correct for. And make your model look nice and linear and clean. It might be a nonlinear or exponential model. It might be nonlinear, multimodal. It could be anything really. And so you could have a graph that for each dependent variable fits a line that describes the behavior of the combination of all of the input variables, where we're used to, our human brains can think about one variable on the X or the input, the independent variable axis, and one variable on the dependent variable, the vertical, the Y-axis, and then the line or curve describing the relationship between those two individual variables. Think about combining a whole bunch of an arbitrary number of input or independent variables into an equation, and all of those are represented on the x-axis. That would be typically more likely a nonlinear or exponential or sigmoidal, an S-shaped graph, or other kinds of statistical models. Okay. Statistical models also include things other than could be a k-means cluster model. It could be a factor. So a factor analysis automatically tests out up to many thousands of combinations of your input variables and says, okay, so these three variables together, they're just related in their behavior to each other. They all describe a different describing what's actually going on in your model according to the data that you fed me, the analyzer. So factor analysis is amazing. It's a powerful way to kind of check your understanding that the independent input variables that you designed for your study, that they're actually tracking with the dynamics of the phenomenon that you're studying. Really, really cool statistical model. So other statistical models might be computer simulation models, like stochastic analyses. If you think about congestion researchers or civil engineering research, and if you're familiar with the computer games Cities and Skylines, or the much older counterpart to that, SimCity, if you're an old fart like me, then computer simulation models are very, very powerful ways to try out, based on the data that you've collected and calibrated on the data that you've collected, to try and build a functional model that behaves the way your real world observations behave. And then you can test all sorts of different conclusions out of that very safely without having to deploy your questions out into the real world and causing things like lots of congestion or car accidents or whatever in a city while you're trying to improve traffic flow, to have fewer cars on the road at any given moment and get them more quickly and safely to their destinations, to reduce air pollution, to reduce asthma attacks and untimely deaths as a function of that. Okay, so computer simulation modeling is a statistical family of techniques. We could also do things like Monte Carlo. So programming your understanding of, or statistically modeling your understanding of your phenomenon using statistical techniques that look suspiciously like casino games, and then having the computer play up to hundreds of millions or billions of rounds of these casino games and seeing what happens. So it's related to computer simulation modeling, not quite the same thing. We can also, as an early statistical model, so this is not one you're doing as a post hoc or after the fact of data collection analysis. Sometimes this part goes in your methods section because it's as you're going. can do a power analysis, which takes a look at a subset, maybe the first couple of rounds of your data collection, looks at the variance involved and says, all right, if you want any of your statistical techniques down here under your ANCOVA, ANOVA, your t-tests and stuff like that, if you want those to be reliable and effective, you're going to need this sort of a sample size versus that sample size because your variance is very high or low among the smaller preliminary data set that you fed into the power analysis. Okay, so again, power analysis might go in your statistical analysis section. It might go in your sampling design section because this tells you how much sampling effort you need to do. Okay. All right, we'll talk more about sampling design and all that stuff later on, as we decided at the beginning of the semester. But for now, we'll just put it right there. Okay, and then once you are talking about your statistical models that you're planning on using in your methods section, well, that's probably going to be one of the last things that you're talking about in your methods section because you got to do all this other stuff to get to the point of being able to do models. You got to know all the characteristics of these individual variables with your univariate stats in order to feed those univariate stats functionally into statistical models. So all of these things build on each other. We generally do them in this order for that reason. Okay, so now we've got methods as that first level heading, chapter title. Underneath that, we've got statistical analyses as the subheading, and then we've got a bunch of content bullet points. So each one of these bullet points might be one sentence in your methods chapter eventually. And you can kind of see how the outer bullet points in the content organize all of these eventual one sentence or list sentences into paragraphs. So multivariate statistics might be one paragraph. Statistical models might be one paragraph across all of them if you're using a couple, or maybe one paragraph each if if the point of your thesis is lots of advanced statistical modeling. Okay, so this gives us a method section that's typically at least a couple of pages and not typically huge because, again, you're not reinventing the wheel on any of these. Most of your readers are going to know what a mean, median, mode, and range is. So you might, what those are. So you might be able to kind of shortcut having to list all those out and like write a sentence for each, which would be really repetitive and kind of a waste of space. For your thesis, you can assume that your committee members all understand what the difference between a mean and a trimean, a geometric mean, arithmetic mean, harmonic mean, what those are, how those are all different. And so you just say, we'll compute central tendency statistics for each of our collected variables. And that covers these 3 bullet points, for example. Okay. But again, we're not doing that today. We're just getting things generally laid out, just kind of splashed out into this real quick, this quick and dirty draft outline. All right. Other methods subheadings that we might have had might include a site description. If you have any humans or live animal organisms involved in your study, you might have a human subject committee compliance. You gotta write out everything you're gonna say, everything you're gonna do with human subjects in detail and get it approved through the university, which takes a minimum of about a month and can take up to a couple of months. So you wanna budget some time out in advance before you're planning on blasting out your survey or your weird Nazi study to shock people and see if that traumatizes folks you're telling to shock them. We'll talk about that, another story for another time. Along that same line, again, if you're working with animals, the IACUC protocol is the one that is federally mandated by the United States government to make sure that you are not abusing animals and causing undue harm or suffering to animal participants in your study. Okay, Cool. So there are other method sections that might go in there. Your site description might not have a lot of words in it. It might be a little bit more map heavy, maybe. Picture's worth 1,000 words or 500 words in terms of publication guidelines. So you don't necessarily have to worry too much about getting into huge amounts of detail on each of these in your method section. But to the extent that your study depends on, cannot generalize past a certain kind of soil for a study. You might say the type of soil in our 3 fields of study or our 2 paired watersheds is an Alfred silt loam. And I know that in my annotated bibliography, I found one study, or maybe it was an NRCS or StatsGo or Surgo soil survey map or geodatabase. I remember that was a web search that I did last week with the Natural Resources Conservation Service 2021. Now I just manually typed this parenthetical reference in as a reminder to me. When I actually go through and put some of these citations in, I'm going to delete that and use EndNote or Zotero or Microsoft Word's built-in citation manager or whatever to put in this citation, and also to generate the literature cited auto-magically at the end, okay? And that's gonna go in, it'll be listed in my table of contents, and then it is one of our top level headings. Works cited towards the end. Okay, so that's basically all we're doing today. And this week and next week and stuff like that. So it's gonna go from outlines to, bullet points to more bullet points to more bullet points to bullet points in order, with increasing numbers of citations for specific things that you didn't invent, and so forth. And the outline just grows and grows and grows. And then a later step will be for us to take each one of these bullet points and turn it into a sentence and make sure it is fully and completely cited instead of just these little scratch notes citations to ourselves. Okay, you've got this. We just put together some real meaningful detail starting from a blank page in less than 1 hour. You can absolutely do this. And you know, for your study, a lot of these things, if you've had any chance at all to talk with your advisor and maybe even your committee about what your study is going to be. Okay, and I know that a few of you taking this class this year are already past this step and you've got a draft proposal and you've already turned that in. You don't need to do this step, all right? But for those of us still kind of piecing it all together, this is how the sausage is made. This is how we piece it together. You can do this, it's low stress. Use each wave or pass through this or brain dump into this as an excuse to work real hard for 20 to 50 minutes, then get up, get away from your screen, even power down your computer after saving this and creating an automated backup that is offsite, secure, and automatic using iCloud or Microsoft's document cloud or Dropbox or any of the bazillions of different cloud saving things, so that while you're out at the gym blowing off stress and being a healthy human being in addition to a worker bee graduate student, as your apartment burns down in the meantime, or as the pipes burst in the ag building, as they have many times in the graduate computer labs, and destroyed equipment recently, like 3 or 4 times in the past 5 years, it doesn't matter. You have a secure automated backup that instantly backed up your work to the cloud, and doesn't matter if you lose that hardware. Okay, cool. Again, you can do this. We'll see you next week.